Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, we will be focusing on the sixth question whereby I'm tackling rates of reactions. Please do note that there will be 11 questions in total, and all of these questions will have their own video, and secondly, they are all extracted from past exam question paper. It's very important for you guys to know how to tackle such questions because it will give you an edge whenever you write your exams. So please do share the video to your peers so that they may have the same edge as you. Okay, the reaction of copper 2 carbonates with excess dilute hydrochloric acid is used to investigate the rate of reaction. The balanced equation for the reaction is given below. The apparatus used is illustrated below. Okay, we do have our conical flask, and inside our conical flask we do have our dilute hydrochloric acid, which is in excess, and we also have the copper 2 carbonate lumps as well. Are you together? Okay, and then the first question, we are being asked to state two ways in which the rate of the reaction above can be increased. We know that guys, the rate of reaction can be influenced by 5 factors. If you increase the pressure, you'll definitely increase the reaction rate. If you increase the concentration of your acid, your rate of reaction will obviously increase the rate. If you increase the temperature, the rate of reaction will increase. If ever you increase the states of division of the copper 2 carbonate lumps, maybe change them from lumps into powder form, the rate of reaction will increase. And if there's an addition of a catalyst as well, the rate of reaction might be increased. So you can choose any of the 5 factors. Okay, now we are told that during the investigation, samples of both pure and impure copper 2 carbonates of equal mass are used. The graphs below are obtained from the results. Okay, the graph below are obtained from the results. Okay, this graph over here, the one that has dotted lines, represents the impure solution, and then the one with the solid line represents the pure solution. Okay, excuse me. Write down the reaction time for the reaction of pure copper carbonates with HCl. Okay, they just want to know how long did it take for this reaction to reach a completion. How will I know that my reaction has reached completion? I would know that my reaction has reached completion whenever I start having a flat line like this. That means my reaction has reached a completion. And obviously my flat line starts somewhere from here over there. I want to know how many seconds is this point over there. How can I find that? There are 10 lines between these. Are you together? So this will be 40, 41, 42, 43, 44, 45, and 46. Are you together? So it took 46 seconds. 46 seconds for the pure solution to reach a completion. Are you together? It only took 46 seconds. Okay, now we must assume that all the gas formed during the two reactions escape from the flask, and the impurities do not react. Okay, calculate the average rate of reaction of the pure sample in 20 seconds. Okay, in 20 seconds, the initial mass was 170 grams, and then in 20 seconds, that's our mass over there. The rate of reaction, I'll calculate average rate of reaction. Remember that, guys, for you to calculate average rate of reaction, it's always the change in quantity all over the change in time. Are you together? The quantity can be the change in the number of moles excuse me, over change in time, change in mass over change in time, change in concentration over the change in time, and the change in the volume of the gas formed all over the change in time. Are you together? It's the change in quantity all over the change in time. Since we are given mass over here, I can simply calculate the rate of reaction by simply saying the rate of reaction is basically the change in mass of my pure solution divided by the change in time. Are you together? Okay, now I want to know what is the mass of the pure solution exactly at 20 seconds. Okay, I just need to find the corresponding value over there. Yeah? Okay, since I have two, between these two numbers, I have 10 lines. Né? I want to know what does each line represent. I'll simply say 169.80 minus 169.75 divided by 10. Okay, this will give me 5 times 10 to the power 3 or just 0.05. It simply means that, guys, all these 10 lines are just 0.05 apart from one another. So basically the value over there will simply be 169.755, and then the value over there will simply be 169. Let me calculate. It's 169.75. Are you together? And then all I have to do is to just add the 5 times 10 to the power 3 twice. Okay, firstly I'll simply get 169.755 as I just said, and then second I'll get 169.76. So the mass over there is just 169.76 grams. So for me to find the rate of reaction, I'll simply say the final mass is just 169.76 minus the initial mass, which was just 170.00. All over the time is 20 seconds. So I have 169.76 minus 170.00 divided by 20. So I'll simply get an answer of negative 0.012 grams per second. Now, this negative, guys, it's just showing that our copper 2 carbonate is decreasing. Are you together? So do not worry about the negative sign. Eh? So we can simply say, therefore my rate of reaction is basically 0.012 grams per second. This is the answer over there. Né? Let's go and write it. The rate of reaction is 0.012 grams per second. Okay, now they want us to calculate the percentage purity of our impure sample. We want to know how pure is this sample of ours over there. Né? Remember that, guys, we were told that for the impure solution, only the pure parts will react. Are you get? So I must just calculate the change in mass or percentage purity. Oh, by the way, né? Percentage purity is equals to percentage purity. This will be equals to since I want to find the percentage purity of the impure solution, né? I'll simply say the change in mass of the impure solution all over the change in mass of my pure solution multiplied by 100. Are you together? Since I don't have space, I'll write over there. Né? Okay. Let me erase. So for the pure solution, the reaction reached completion over there. This is the value where it reached completion. Yeah? So for me to know what is that value, remember that, guys, all these lines are just 0.005 apart. Yeah? So this line over here will simply be 169.705, and then this will be 169.71, 169.715, 169.72, then 169.725, and then the value over there is just 169.73. And then for the impure solution, the completion was reached at this point. Okay, so I'll simply have 169.755, 169.76, 0.765, 0.77, and that value over there will just be 169.78. Okay, then for me to calculate my percentage purity, I know that I'll simply say the change in mass of the impure solution, that's 169.78 minus the initial mass, which was just 170.00, all over 169.73 for the pure solution, all over 170.00 times 100. So this will simply give me the percentage purity. 169.78 minus 170.00 all over 169.73 minus 170.00, multiply that by 100. You'll simply get percentage purity of 81.48%. 81.48%. That's our percentage purity, né? 81.48%. Okay, now they want us to calculate the maximum volume of carbon dioxide produced during the reaction of the standard pure sample of copper carbonate if the reaction takes place at standard conditions. Né? Okay, firstly, I know that the mass of my impure solution that will be used. Are you together? I can call it the change in mass. Né? The mass of my pure solution that will be used, I'll simply say initially I had 170, but then after completion I was left with 169.73. Are you together? Remember that, guys, the value over there, it was just 169.73. Né? Okay, and then my change in mass will simply be 170.00 minus 169.73. 169.73. And my 9 over there looks like a 7. So I'll simply get 0.27 grams. This is the mass of my pure copper 2 carbonate that was consumed. Are you together? So I can simply find the number of moles which were used to form carbon dioxide. The number of moles of my copper carbonate, I'll simply say this is mass all over the molar mass. Are you together, guys? Mass all over the molar mass. From the periodic table, copper is, let me check, 63.5. So my mass is just 0.27. It differs, guys, with the periodic table. Né? Some of the periodic table, they prefer writing whole numbers. You might find that in some of the periodic tables, you have 64 as your copper as your copper. Are you together? So please do check your question paper, please. So I have 63.5. I know that carbon is equal to 12 and oxygen is equal to 16, but since I have 3 of them, I'll multiply by 3 over there. So the number of moles is basically I'll simply say that 0.27 divided by 63.5 plus 12 plus 16 times 3. So this will basically give me, I'll simply say this is 2.1862 times 10 to the power negative 3 moles. Are you together? These were the used number of moles for my pure solution. So since, guys, there you can see that the stoichiometric coefficients, I have 1 and 1. Yeah? So this simply means that the number of moles of my carbon dioxide will simply be the number of moles of my copper carbonate which were used. I'll simply get 2.186 times 10 to the negative 3 moles as well. Yeah? So for me to calculate the volume, number of moles is equal to volume all over the molar volume. Remember that, guys, we were asked to assume that the standard conditions were kept constant. Né? If the standard conditions are constant, it simply means that the molar volume is just 22.4 cubic decimeters. And then over there, I simply have 2.186 times 10 to the power negative 3. I'm looking for the volume. Therefore, 2.186 times 10, it's 1862. 2.1862 times 10 to the power negative 3. And then we multiply this again with 22.4. So the volume which will be formed will simply be 0.048988, and this can be rounded off obviously into 0.05 cubic decimeter. Excuse me. Okay, now they asked us to sketch the graph of the volume of the gas produced for the reaction of the pure copper carbonate. Initially the gas produced, since there were not product forms in the initial stages of the reaction, that means this will move like this, and obviously it will reach completion. It reaches completion after 46 seconds. Remember that, né? For the pure solution, it will reach completion after 46 seconds. This will be time measured in seconds. And then over there, I'll simply have the change in volume of my gas. Volume of carbon dioxide. And this is measured in cubic decimeter. So your graph will just look like this, guys, né? Yeah, so just stay tuned and please wait for more videos. Thank you.